we're going to go through the lesson, which is trig. So it's been a while since you've covered trig, but we're going to try to review all of the skills you need. So first, today's lesson is going to be mostly on reviewing some of the trig and talking about what an angle in standard position is. So you're going to have to go to your note package that I gave you for trig, and this, again, the order is mucked around with. So move past the first lesson and then into this one. So basically, we're going to talk about angles. So an angle is basically formed by two rays with a common endpoint. So when they use the word rays, we're just talking about two lines that connect at a specific point. So here's my endpoint. I have two lines, one going this way, one horizontal. And then the angle that it's formed, we're going to use the symbol theta to describe that angle. So this is just a symbol. We give the name initial arm for where we start to make our angle from, and then we move this arm towards another spot, and wherever that arm ends up, we call that the terminal arm. So this is my initial arm. This is my terminal arm. And then the angle that's formed goes right in between, and we call that angle theta. So basically, if I talk about an angle in standard position, we want to consider the positive x-axis. So here's my coordinate axes. An angle in standard position will always start with its initial arm on the x-axis. So this is my initial arm, and we're always going to rotate in a counterclockwise direction. So counterclockwise direction means that I have a positive angle, and if I go down first and go in a clockwise direction, I'm forming a negative angle. Okay, so we're going to start on the initial arm. We're going to move this initial arm and rotate it. And wherever I want to stop my rotation, again, this angle theta would be called the angle in standard position. So I'm going to just say angle theta is the angle in standard position. Okay. So again, if we rotate clockwise, the angle is positive. So for example, the red angle that they start with, here's the red that starts my initial arm. I rotate in a positive, well, in a counterclockwise direction, which means I'm rotating in a positive angle direction. I end off at my terminal arm. So this angle that's formed is theta 1, and angle theta 1 is the positive angle. If likewise, if I start on the positive x-axis and then move in a clockwise direction, and then I decide to stop my terminal arm here, then angle 2 is my angle, and it's going to be a negative angle because I moved in a clockwise direction. So again, CW is clockwise, and CCW is counterclockwise. Okay. Now basically, angles in standard position will always be shown in one of the four quadrants. It doesn't matter which direction you move. It doesn't matter how many times you rotate around. The angles will sit in one of these four quadrants. So we label the positive x, positive y coordinate quadrant 1. This quadrant, quadrant 2, quadrant 3, and quadrant 4. And if you're not good at reading Roman numerals like I'm not, then I like to just visualize this with just numbers in it. So 1, 2, 3, and 4. So when I'm in quadrant 1, I can have any angle between 0 and 90 because I'm staying within that first little L section. So my angle is going to be between 0 to 90 degrees. Okay. When I'm in quadrant 2, now all of a sudden I've sort of got to the 90 mark, and then I want to stop at the 180 degree mark. So my angle is going to be 180 degrees 90. So my starting point will be 90, and then my angle can go all the way up to 180 degrees, and 180 degrees is just a straight line, okay? So 90 degrees is like this, 180 is horizontal. Quadrant 3, if I'm in quadrant 3, I'm going to be starting at 180 and then going 90 degrees more than 180, which lands me at 270 degrees. So I can have my angle anywhere between 180 and 270 degrees. And then finally, quadrant 4 would be I start at the 270 and then get back to the 90 degrees more than 270, which is 360, which is like you making a full circle. So that would be my full circle around, and I've already made it to 360 degrees, but I'm only focusing on getting there from, the 270 to the 180 mark, or to the 360 mark. Okay. Now, basically, for every angle that sits in standard position, so remember, standard position means I draw my coordinate axes, I start my initial arm, I move in a counterclockwise direction, and I stop somewhere. So for any angle that I form, there's going to be always an acute angle, and acute means less than 90 degrees. And this angle that's acute is called a reference angle. So if I'm looking at my diagram above, my acute angle would go from the terminal arm to the closest x-axis, which is down here, and this angle is my reference angle. So we label it theta reference, or you can use theta ref to talk about my reference angle. Okay, so theta ref will be the notation I use for it, or if I'm using x as an angle, I can be talking about my x reference angle, and so forth. Okay, again, the reference angle is always between the terminal arm and the x-axis, and you want to move to the closest x-axis so that you're forming an angle that's less than 90 degrees. So let's look at an example. Okay. Draw an angle in standard position in each quadrant and then identify the reference angle. So I'm going to draw my angle in standard position, start on the terminal arm. I want to stay in quadrant 1. So here's my terminal arm. Here's my x-axis. I'm moving in a counterclockwise direction, so I'm going to show that. And this angle here is my theta reference, if I was in quadrant 1. If I was in quadrant 2, it means my angle starts on the x-axis, and I keep moving all the way till I land in quadrant 2 in a counterclockwise direction. Over here, this is my rotational angle, the theta rotational. That's how much I rotated. But my reference angle would be the angle between the x-axis and the terminal arm that forms an angle that's less than 90 degrees. So this would be my reference angle. If I'm in quadrant 3, I start at my positive x-axis, I rotate, 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 and I get somewhere in quadrant 3. I'm moving in a counterclockwise direction, so here is my rotational angle. I'm going to abbreviate it now. And then my reference angle would be from the terminal arm to the x-axis. This would be my theta reference. And finally, if I'm in quadrant 4, I haven't used red, I'm going to start at the positive x-axis, move in a counterclockwise direction until I want to stop, and then I rotate my angle until I get to the terminal arm. Here's my theta rotational angle, but my reference angle is from the terminal arm to the positive x-axis. So here's my reference angle. And again, in all of these examples, theta reference is smaller than 90 degrees. Okay, we don't want it bigger than 90 degrees, so you need to form the reference angle so that it's always smaller than 90 degrees. Okay, so let's actually work through some examples. Draw an angle in standard position. So we're going to go ahead and do that and state the reference angle. So I draw, as soon as they use the word standard position, it should clue you in right away we're drawing our coordinate axes. I want to draw my angle, which is 210 degrees. So this is 0. This is 90. This is 180. This is 270. Okay, so 270, 0, 90, 180, 270, and then when you get back to the 0 line, you've made it a full 360. So I'm going to draw my angle starting positive x-axis, and 210 would be somewhere here. You can approximate it. That's not a big deal. There's my theta, which is 210. That's my rotational angle. My reference angle is going to be the one between the x-axis and the terminal arm, so it's right here. So how am I going to figure out my reference angle? Well, my theta reference is going to be equal to, well, going from here to here is 210 degrees. But then I know if I stop at this line, this angle is 180 degrees, so I'm going to subtract off 180 degrees. And then I'm going to get the leftover bit, which is this much, which represents my reference angle, which is 30 degrees in this example. Okay, again, we want to draw angles in standard position. So I'm going to go ahead and draw my axes. As soon as you see the wording standard position, we want to start here. Just as a little reference, you might want to write down your main 4 angles that are 90 degrees apart from one another. So you can go 0 plus 90 is 90, 90 plus 90 is 180, 180 plus 90 is 270, 270 plus 90 is 360. So now 145 degrees sits somewhere in quadrant 2. So I'm going to start my angle on the positive x, land somewhere in quadrant 2. I'm just going to approximate it. There's my rotational theta, which they've labeled just theta. So my reference angle would be the angle from the terminal arm to the x-axis, and there's my reference angle. Okay. Now I know if I go from this point all the way to this point, I've traveled 180 degrees. So my reference angle has to be that total distance, 180 degrees, but I want to minus off the 145, which gets me to that point. And then the leftover amount of that would give me my reference angle. So in this case, my reference angle is 35 degrees. Let's draw in the next one. Here is 0. Here is 70 degrees because I know I'm smaller than 90. This is my theta rotational. My reference angle will be the distance from the x-axis to the terminal arm. So my theta reference is also in this position. So my theta reference is actually equal to just my rotational angle, which is 70 degrees. Finally, let's look at the last example. 315, so there's 0, 90, 180, 270. Somewhere in here will be 315. I don't care where, as long as I know it's in quadrant 4. My rotational angle is 315 degrees. My reference angle is from the terminal arm to the x-axis. There's my reference angle. To find my reference angle, well, I know that if I travel a little bit more from the 315, I get to 360. So if I take the full circle and subtract off how much I've traveled, which is 315, 20, so that would be 45 degrees as my reference angle. In any question I give you, it is important that you're able to find the reference angle, and you have to be able to draw the rotational angle. Things to look out for is rotational angles have directions attached to them. So all of these rotational angles, I have directions attached to them. But the reference angles are just like magnitudes. How much is this distance? How much is this distance? how much is that distance. We're not going to put a sign attached to the reference angle. We're just going to measure how much is that as kind of a movement of space. So 45 degrees of space moved, it doesn't matter the direction. Okay, what four angles have a reference angle of 60 degrees? So this is a little bit tricky because now I'm going to give you a diagram, and my diagram depends, like this, my reference angle doesn't depend on what quadrant I'm in, but the rotational angle will depend on what quadrant I'm in. So in all of these examples, I'm going to draw a reference angle of 60 degrees, but I'm going to draw it in the different quadrants. Quadrant 3. And again, it's always going to be attached to the x-axis because that's where it is. I'm going to attach my reference angle from the x-axis to my terminal arm. So now my rotational angle starts in standard position at the positive x-axis and moves towards that line. So in this example, my reference angle ends up being 60 degrees because it's the same as the rotational. In this example, this time around, 60 degrees is how much my reference is, but if I want my rotational angle, I can go all the way up to this line, which is 180 degrees. And sorry, I shouldn't call this reference, I should call it rotational. So in the second example, I'll use a different color. So this purple is how much I need to move. So I know my answer is between 0 and I sit in the second quadrant, so it has to be smaller than 180 but bigger than 90. If I go rotational angle, if I go all the way to this line, I've traveled 180 degrees. If I subtract off my reference angle of 60, I can get how much I've moved in the positive direction, which is not 130 because I can't subtract, 120 degrees. If I'm in quadrant 3, pay attention to how I'm going to do this. I'm going to go to the 180 line, and then when I get to this line, it's 60 degrees more than the 180 line. So in this case, my rotational angle is 180 plus the reference angle I traveled, which is 60, which will give me 240 degrees. And in quadrant 4, dark green, I go from here all the way to here, but if I were to keep going, I would have traveled 360. So my rotational angle is the full 360, but I want to take away that little bit from the x-axis, which is 60, and then I get 300 degrees. So those four angles represent all having a reference angle of 60 degrees, but all coming from different quadrants. So this is coming from quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So you can have a reference angle in whatever quadrant you want. You would just want to have that specified so you know what quadrant to start over. Okay, determine theta 2. So find an angle if one of my angles is 40 and I reflect that 40 over the x-axis. So over here, I have a 40-degree angle in standard position. I want to reflect that angle over the x-axis. Okay, so I'm assuming that this is what they're referring to for theta 2. How much have I traveled to get to theta 2 when theta 1 is 40 degrees? Well, I know that if this little bit is 40, then this little bit is 40 as well. So to get my theta 2, all I have to do is take my full 180 degrees to get to the straight line, take away the little bit, that's my reference angle, and I get 140 degrees. So that's my angle starting from here, ending over here. We're going to reflect our angle in the x-axis this time. So I take my 40 degrees. I want to reflect this angle into the x-axis, which means I'm going to get 40 degrees down this way. And now I'm interested in finding my rotational angle, which goes like this. And I'm going to call this one theta 2. So theta 2, to get that angle in quadrant 4, I want to go back to the full line, which is 360 degrees. I take away the little bit of purple that I have, which is 40, and my final answer is 320 degrees. Finally, if I reflect in both the x and the y-axis, so here's my 40 degrees. I'm going to reflect in the y and then in the x. So I'm going to erase this helpful line, and I'm just going to put the 40 degrees in here. And now I'm interested in, let's use blue. I'm interested in how much I moved from here to get to quadrant 3. So this question is literally like the one we just did, except they don't tell you it's a reference of 40 in each diagram, but because I'm reflecting it, it is a reference of 40. So this angle in blue, starting from the positive x-axis in standard position, moving in a counterclockwise direction, stopping at this line. When I get to this line, I've traveled 180. And then I travel 40 degrees more than that 180 line, and I get 220 degrees as my angle. Okay, so what you can work on is, there's an assignment, it's not really an assignment, but practice, and it's on page 83 of the textbook online, and you can practice 1 to 7, 9, and 14, and then, just ask questions if you have any.